Welcome to Summer School Day 2. I hope you all did a wonderful job on your assignment yesterday. If you feel like you need additional help, please reach out during office hours. I'm available from 9 a.m. to 12 p.m. to provide assistance with the daily lessons. If those times don't work for you, please reach out to set up alternative times. You can find my phone number on the syllabus and on the first announcement on Google Classroom. So let's get started with our lesson for today. Today's objective, students will be able to compare the properties of multiple linear functions and write comparison statements. When we see this term linear functions, I just want you to remember we are talking about a line, the equation of a line. You are familiar with the equation of a line, so don't let the vocabulary intimidate you. Let's look at some things we should already know. Remember, when you are given an equation in slope intercept form, you're given two very important features, the slope of the line and the y intercept of a line. All right, it's important to remember whatever the sign is in front of this y intercept has to stay with it. So in this case, our y intercept is -5. That means our line would cross the y-axis at the point 0, comma, -5. We'll get into a little bit more about that later. Also remember, you can find the same information if you're given just the graph of the line. If you're given the graph of the line, you're going to locate the point where the line crosses the y-axis, and that is your y-intercept. In this case, our y-intercept is 3. So our b is equal to 3. We can also calculate the slope of a line if we're just given a graph. You can do this one or two ways. You can calculate the rise over the run by counting from one point to another. So you can count how many points does it take to get up to this other point? 1, 2, and then you go over to the right 1, and that is your run, and that gives you your slope, your rise over run. 2 over 1, it can be reduced to just 2. Important vocabulary to write down. Pause the video here and fill out your notes on page 2 to catch yourself up with everything we've just reviewed. Remember, slope is the rate of change. The y-intercept is the place where the line crosses the y-axis. So let's get started. Let's compare two functions. Which function has the greater slope? I'm going to underline the word slope. Remember, we're talking about the rate of change. So one easy way that we can tell the slope of an equation is just by looking at the setup. Look over here at this poster. The slope is our m value, so whatever number is in that m spot, and the y-intercept is our b value, whatever number is in the b spot. So just by looking at this function b, what's our slope and what's our y-intercept? I'll give you a second to think. All right, let's check your answer. So if you said the slope is 1/2, then you are correct. If you said the y-intercept is 10, then you are correct. Easy, right? When given an equation in slope-intercept form, it's really easy to see what the slope is and what the y-intercept is. You just have to remember their positions. Let's look at our graph. We're not given the slope, but we are given points on the line, perfect points on the line. So I'm going to choose 2 points on the line, and I'm going to calculate my slope. Remember, we can do this one or two of two ways. We can calculate our slope by counting, simply doing the rise over run. So I can count from this point up to this point. How far did I go up? I went up 1, 2. How far did I go over? I went over 1. So my slope here is rise 2, run 1, 2 over 1. I can reduce this fraction to just be equal to 2. Okay? This method only works if your intervals are going up by 1. So you have to be careful and you have to look at your graph. Another way to be sure that we're calculating our slope the correct way, even if the intervals are not 1, is by using the equation that we see right over here. Y2 minus y1 divided by x2 minus x1. I'm going to show you how we do that. So here's a reminder. Here's our slope. We did it rise over run. We found it was 2. But if you would want to use this equation, we simply find our 2 points. We're going to write them as ordered pairs. So remember, your x value comes first in your ordered pair. I'm going to label this x and our y. Okay. This is our first point. So this is my x1 and this is my y1. This is my second point. So this is my x2 and this is my y2. All right. So now I just substituted these values in just like my equation says. I took my y2, which is 2, and I subtracted it from 0, which is my y1, and that gave me 2. I took my y2, my x2, I'm sorry, and I subtracted it from my x1, which was negative 1. Remember, anytime we have a negative and minus a negative, we have to distribute that negative and it becomes a positive 1. So I'm left with positive 2 over 1. I can reduce that and my slope is 2. Again, remember, we use this formula to make sure that our slope is accurate. We can't always count on counting rise over run because sometimes the intervals are not 1. Pause your video and make sure you are copying this down in your notes. All right, so now that we know the slope of each function, we can write our comparison statement. I'm going to show you our slopes just as a reminder. Our slope of this function b is 1/2, and our slope of function a is 2. So now we can answer this question. Which function has the greater slope? Greater meaning the largest slope. I want you to think, what do you think our comparison statement should be? Let's look at it. Function A has a greater slope than function B. Give yourself a pat on the back if you got it right. All right, so let's go to our next comparison. Which function has the greater y-intercept? Again, we can easily find the y-intercept from our equation because we know whatever number is in the B position is our y-intercept. So our y-intercept for function B is 10. When given the graph of a line, you can still easily find the y-intercept. You're just looking for the point where the line crosses the y-axis. So where does this line cross the y-axis? If you said 2, you are correct. So which function has the greater y-intercept? Which function has a y-intercept that is larger? Think about your comparison statement. Try writing it down in your notes. Let's check and see if you're correct. Function B has a greater y-intercept than function A. All right, so let's compare two different functions. We have a different graph and we have a different equation. Which function has the greater y value when x is negative 8? Now, this one is a little different because you are given an x value. X is negative 8. How do you think we could solve this? Well, if we want to find the value of y when x is negative 8, we can first start with our graph because that's really easy to see. I'm going to look at my x-axis and I'm going to find negative 8. Here it is. And I'm going to find y. Here it is. So when x is negative 8, my y value is negative 2. Let's look at function b. How are you going to tell what your y value is when your x is negative 8? Now we're going to do a little bit of algebra. We're going to substitute in negative 8 where we see our x, and we're going to do that math. 3 over 4 multiplied by negative 8 is negative 6. -6 minus -2 is equal to -8. So which function has the greater y value when x is -8? Function A has the greater y value when x is -8. So when you're finding the y value when given an x value, remember, you can simply look at your graph or you're going to substitute your value into your equation. All right, so now it's your turn to practice. You are going to practice skill S.15 or .15 on IXL. Remember, your goal is to reach a SMART score of 100. Be really careful as you practice because the more questions you get wrong, the longer it's going to take for you to finish it. But if you take your time and you get the questions right back to back to back, you'll finish in no time. Good luck, and remember, I am available for office hours if you need help.